here in just a minute. So our first problem that we have here, we have y equals x squared plus 2x minus 15. And I want to take this parabola and I want to rewrite it in a factored form. All right, and the way that we do this is we use what's called a box and diamond method. So you might remember this from Algebra 1, where we draw a box. It looks like this. Right? We would draw a box and we would divide it into 4 compartments here. 4 smaller boxes. And your Algebra 1 teacher might have referred to this as a generic rectangle or some other name. I call it a box with, so nothing special here. All right. Now, what we would do is we would start off by taking the first part of our quadratic, the x squared term, and we would put it here in the upper left-hand box. So I would say x squared would go here. The last term, the negative 15, goes in the bottom right-hand corner. And then from here, to figure out what goes in these 2 boxes, that is dependent upon the 2x, right? So this 2x needs to be split up somehow between these 2 boxes, and how we split that up is actually dependent upon the diamond. Okay, so we know that these 2 boxes have to add to give us 2x, because that's what's left of our equation here. So I'm going to put a 2x in the bottom of my diamond. The other thing that we know is that these 2 boxes, this diagonal right here, the x squared and the negative 15, have to multiply to give me the same thing as my blank diagonal. So if I multiply negative 15 and x squared, I get negative 15x squared. So I know that this diagonal has to multiply to give me the same thing, and at the same time it also has to add to give me 2x. So I'm looking for 2 numbers that multiply to give me negative 15 and add to give me 2. All right, so I kind of wrote that down here for you so you can think about those 2 numbers. All right, and for this one, what we're going to find is that we need a positive 5 and a negative 3. And I'm going to make sure that I put x's on there, just like that. All right, so if I do 5 times negative 3, I get a negative 15. If I do 5 plus negative 3, I get my 2. All right, and the reason that I added the x's on there is because we really need to get an x squared up here, and we just need an x down here. So x times x gives me the x squared, and then when we do 5x plus negative 3x, we get 2x. All right, so now I know what I'm going to put in my other diagonal here. So I'm going to say 5x here and negative 3x here. And it really doesn't matter what order you put them in. Okay, so now what I'm going to do is I'm going to switch colors here to, let's go with green, and I'm going to start working on my outside numbers. All right, so each of these are rectangles, and if you can think, they have a height and they have a width, and when I multiply the height and the width of each of these little boxes here, I have to get what's inside, right? So a way to get x squared would be x times x, right? So x times x gives me x squared. And if I have an x here representing this length, then I'm going to have an x over here representing this length. And then same thing, if I have an x up here, I have an x down here. All right, so now I'm thinking about negative 3x, right? So x times something has to give me negative 3x. Well, that has to be a negative 3, right? Because negative 3 times x gives me negative 3x. Then by the same logic, I would have to have a 5 over here, because x times 5 gives me 5x. Okay, and then if I transfer those over, right, I would do 5 times negative 3 to get my negative 15. All right, now notice the entire side length of the big box, right? So if I look at the entire box, notice my entire side length here is x plus 5. And my height over here is x minus 3. So essentially I have 2 dimensions for the big box. All right, so if I want to write my factors, as we call them, we're going to say x plus 5 times x minus 3. Okay, so there's my factored form, right? Just like we see it up here. So x plus 5 times x minus 3 is the same thing as what we started with. It's the same parabola, but written in a different way.